EVS29 EV Regenerative Acceleration Demonstration and Performance Test Data. EV Regenerative Acceleration Product Demonstration and Performance Test Data as demonstrated during prepared by Thane C. Hines Regen Extra Incorporated. CTO date, June 28, 2016. Regen Extra Incorporated Regenx demonstration during EVS June 29, 2016. The electric vehicle, EV, regenerative acceleration, Regenx, innovation employs a load current delay in order to reverse the electric vehicle regenerative braking paradigm and allow for continuous battery recharging during all modes of EV operation. Regen Extra has conducted significant research and development on the Regenx innovation since the original regenerative acceleration discovery in 2007. This demonstration incorporates 3 different prototypes. Each one has been built to showcase the various aspects of the regenerative acceleration innovation. Regen Extra Incorporated. Regenx product demonstration during EVS June 29, 2016. The 3 demonstration prototypes include the following: 1. Regenx generator prototype number 1, incorporating a conventional generator coil and a Regenx generator coil placed on the same core, highlighting the load current sine waves of each coil. Conventional generator coil regenerative braking, and regenerative acceleration as caused by the Regenx generator's load current delay. 2. Regenx generator prototype number 2, operating above and below the Regenx coil's critical minimum frequency. 3. Regen X motor prototype number 3, demonstrating Regen X motor action with simultaneous Regenx generator action. Demonstration prototype number 1 EV regenerative acceleration generator load current delay. Regenx generator prototype number 1 incorporates a conventional generator coil and a Regenx generator coil. Both coils are placed on the same core and influenced by the same rotor magnets at the same time. This prototype showcases how and why the regenerative acceleration phenomenon is produced. The Regenx coil load current is delayed by approximately 45 degrees. This load current delay as demonstrated on the oscilloscope is responsible for EV regenerative acceleration because delaying the coil's load current also delays the coil's induced magnetic field and how and when this induced magnetic field affects the rotor. Demonstration prototype number 1 EV regenerative acceleration generator load current delay. EV regenerative acceleration generator load current is delayed by 45-70 degrees. Conventional generator coil's load current sine wave is shown in yellow on the oscilloscope. The Regenx generator coil's load current is shown in blue. After the conventional coil's load current peaks, center line on the oscilloscope, the rotor magnet begins to move away from the coils. The Regenx coil's delayed load current produces a delayed induced magnetic field which assists the rotor magnet's departure. Video demonstration prototype number 1 EV regenerative acceleration generator load current delay. Demonstration prototype number 1 EV regenerative acceleration generator load current delay. https://youtube/tnjkc_pd9uo. Performance data. EV regenerative acceleration generator demonstration prototype number 1 no load system speed equal 3505 rpm prime mover input current equal 1.53 a generator load current equal 0.00 a. The prime mover's input current is a reflection of the drive shaft torque being supplied to the generator. At the steady state speed of 3505 rpm, or any equilibrium condition / steady state speed, the net drive shaft torque and net power are both 0 because drive shaft power equal torque x speed. Performance data. EV regenerative acceleration generator demonstration prototype number 1 on load conventional generator coil, EV regenerative braking, system speed equal 3486 rpm prime mover input current equal 1.65 a generator load current equal 0.88 a. The prime mover's input current and prime mover supplied drive shaft input torque supplied to the generator has increased due to the conventional generator coil's load current and the corresponding resistive induced magnetic field. At equilibrium the steady state speed of 3486 rpm the net drive shaft torque and net power are both 0 because drive shaft power equal torque x speed. Performance data. EV regenerative acceleration generator demonstration prototype number 1 on load Regenx generator coil, EV regenerative acceleration, System speed equal 3508 rpm, prime mover input current equal 1.52 A, generator load current equal 0.93 A. The prime mover's input current and the drive shaft input torque supplied to the generator have both decreased due to the regenerative generator coil's load current delay and the corresponding assistive induced magnetic field. The regenerative generator coil's load current delay creates a complementary electromotive torque which accelerates the EV while recharging its batteries, and while reducing the prime mover input power consumption to below no load levels. Prototype number 1 data summary. Prototype system speed RPM, input current amps, load current amps. Prototype number 1 no load 35051.530.00. Prototype number 1 on load conventional generator mode, EV regenerative braking, 3486 1.650.88. Prototype number 1 on load regenerative generator mode, EV regenerative acceleration, 3508 1.520.93. Prototype number 1 data analysis. Conventional generator mode, EV regenerative braking operation when placed on load and when delivering load current. The conventional generator created counter electromotive torque, EV regenerative braking, which decelerated the system. The prime mover's input current increased and the prime mover's input torque supplied to the generator also increased. The greater the magnitude of load current supplied by the conventional generator to the load, the faster the rate of system deceleration. Prototype number 1 data analysis. Regenerative generator mode, EV regenerative acceleration operation when placed on load and when delivering load current. The regenerative generator created complementary electromotive torque, EV regenerative acceleration, which accelerated the system. The prime mover's input current decreased and the prime mover's input torque supplied to the generator also decreased. The greater the magnitude of load current supplied by the regenerative generator to the load, the faster the rate of system acceleration. Demonstration. Prototype number 2 EV regenerative acceleration generator, regenerative generator. A single salient pole regenerative generator coil prototype. The regenerative generator prototype showcases regenerative acceleration, EV battery recharging with a complementary electromotive torque and the capability to also produce regenerative braking/counter electromotive torque when recharging the batteries in regenerative braking mode. When operating at 3500 rpm or above the regenerative coil's critical minimum frequency, the regenerative generator coil operates in regenerative acceleration mode and recharges the EV's batteries without deceleration of the vehicle. When operated at 2200 rpm, or below its critical minimum frequency, the regenerative generator coil operates in conventional regenerative braking mode, i.e. recharging the EV's batteries, producing a counter electromotive torque and decelerating the EV. Video demonstration. Prototype number 2 EV regenerative acceleration generator demonstration. Prototype number 2 EV regenerative acceleration generator. https://youtube/dfyqmtc9ziac. Performance data. EV regenerative acceleration generator demonstration. Prototype number 2 no load regenerative generator coil, system speed equal 3508 rpm, prime mover input current equal 3.41 A, generator load current equal 0.00 A. The prime mover's input current is a reflection of the drive shaft torque being supplied to the generator. At the steady state speed of 3508 rpm, or any equilibrium condition/steady state speed, the net drive shaft torque and net power are both zero because drive shaft power equal torque x speed. Performance data. EV regenerative acceleration generator demonstration. Prototype number 2 on load regenerative generator coil, EV regenerative acceleration, system speed equal 3510 rpm, prime mover input current equal 3.37 A, generator load current equal 1.46 A. The prime mover's input current and the drive shaft input torque supplied to the generator have both decreased from the no load levels due to the regenerative generator coil's load current delay and the corresponding assistive induced magnetic field. The regenerative generator coil's load current delay creates a complementary electromotive torque which accelerates the EV while recharging its batteries, and while reducing the prime mover input power consumption to below no load levels. Performance data. EV regenerative acceleration generator demonstration. Prototype number 2. Performance data EV regenerative acceleration generator demonstration prototype number 2 operating below the critical minimum frequency. The primary factor dictating regenerative acceleration performance is frequency of operation, because frequency of operation dictates the coil's impedance from the equation Zt equal XL plus RDC, where the coil's inductive reactance is XL equal to FL, such that Zt equal to FL plus RDC. When the coil's operational frequency F is increased, the coil's impedance Zt also increases. When impedance increases, load current flow decreases, and if Zt is high enough, load current flow ceases altogether. When load current flow ceases, the regenerative coil cannot store energy in the electromagnetic field around the coil as an inductor, and is forced to store energy electrostatically inside the coil as a capacitor. When the induced voltage in the regenerative coil exceeds the dielectric's ability to store it, the dielectric breaks down and load current begins to flow, but the delay has already occurred, and the regenerative coil's delayed load current peaks when the rotor magnet is now moving away from the coil. The result is the receding rotor magnet's departure and the approaching rotor magnet's approach are both accelerated in the process, while load current is delivered to the EV's batteries without deceleration of the EV. Video demonstration prototype number 2 EV regenerative acceleration generator operating below the regenerative generator coil's critical minimum frequency. https://youtube/phasem-jib0. Performance data EV regenerative acceleration generator demonstration prototype number 2 operating below the regenerative generator coil's critical minimum frequency. No load regenerative generator coil, EV regenerative braking, system speed equal 2233 rpm, prime mover input current equal 6.19 A, generator load current equal 0.00 A. Performance data EV regenerative acceleration generator demonstration prototype number 2 operating below the regenerative generator coil's critical minimum frequency. On load regenerative generator coil, EV regenerative braking, system speed equal 1937 rpm, prime mover input current equal 6.47 A, generator load current equal 1.40 A. Prototype number 2 data summary prototype system speed rpm input current amps load current amps prototype number 2 no load 35083.410.00 prototype number 1 on load regenerative generator mode, EV regenerative acceleration 3510 3.371.46. Prototype number 2 no load, below critical minimum frequency 2233 6.190.00 prototype number 2 on load, EV regenerative braking 1937 6.471.40. Prototype number 2 data analysis operation above and below critical minimum frequency EV regenerative acceleration and regenerative braking. When the regenerative generator is operated above the regenerative coil's critical minimum frequency in regenerative acceleration mode, the system accelerates on load and the torque supplied by the prime mover decreases as the EV's batteries are recharged. When operated below the critical minimum frequency in regenerative braking mode, the system decelerates as the EV's batteries are recharged. Demonstration prototype number 3 EV regenerative acceleration motor regenerative motor, a single coil motor prototype that delivers mechanical output power and electrical output power. The regenerative motor showcases EV motor operation simultaneously with regenerative generator action, i.e. battery recharging during motor mode/EV acceleration. The regenerative motor prototype demonstrates how the regenerative motor's input current, that is responsible for creating the motor's torque and accelerating the EV, can also be returned to the battery and recharge the battery at the same time. This is achieved because the regenerative generator creates a complementary electromotive torque that is manifested in the same direction as the motor coil's torque. Performance data EV regenerative acceleration motor demonstration prototype number 3 regenerative motor input current equal 0.56 A, output current equal 0.76 A. Performance data EV regenerative acceleration motor demonstration prototype number 3 regenerative motor input current equal 0.77 A, output current equal 0.93 A. Performance data EV regenerative acceleration motor demonstration prototype number 3 regenerative motor input current equal 0.81 A, output current equal 1.09 A. Performance data EV regenerative acceleration motor demonstration prototype number 3 Regen X motor input current equal 1.34 A output current equal 1.45 A. Video demonstration prototype number 3 EV regenerative acceleration motor Regen X motor demonstration prototype number 3 https://youtube/sx0gbxq9jps. Prototype number 3 Regen X motor data summary prototype system speed RPM motor input current amps motor output current amps Regen X motor prototype number 3 100 0.56 0.76 Regen X motor prototype number 3 250 0.77 0.93 Regen X motor prototype number 3 500 0.81 1.09 Regen X motor prototype number 3 750 1.34 1.45. Prototype number 3 Regen X motor data analysis. The Regen X motor circuit allows for the input motor current to be used to establish magnetic field around the Regen X motor coil as per conventional motor operation. The motor coil's magnetic field is then allowed to collapse back into the coil and back into the EV's batteries in tandem with Regenx generator action, complementary electromotive torque. EV regenerative acceleration, this allows for battery recharging during vehicle acceleration. Video demonstration EV regenerative braking tutorial EV regenerative braking tutorial https://youtube/VAA1S4PN62. Video demonstration EV regenerative braking tutorial Regenx generator load current delay explained how the Regenx generator's load current delay creates EV regenerative acceleration https://youtube/huckfings2v8. Video summary EVS29 EV regenerative acceleration demonstration summary https://youtube/xnfs. Conclusions. The EV regenerative acceleration, Regenx, innovation now allows for continuous EV battery recharging during all modes of EV operation. During EV acceleration, coasting, and during braking. EV range extension is dictated by the magnitude of regenerative acceleration recharge current supplied by the Regenx unit. EV battery size and storage capacity is no longer a determining factor with regards to EV range. Contact Regen Extra Incorporated. Gail L. Snuggs, co-founder and CEO. gl.snuggs@regenextra.com. Thane C. Hines, co-founder and CTO. Thane.hines@regenextra.com.